everyone. Thank you for joining us today. My name is Gary Chu, the co-founder and co-director of synHacks and Hack the World, and we're very excited to have Muddassar with us today. He'll be giving us a quick talk about the different career paths for software engineers. But before that, I would like to introduce Anne, our other co-founder.
Hi, I'm Anne. So Muddassar will be talking about how once after you get your degree in computer science, you go into the software field, and he'll be talking about the different career paths after you get your degree. So I'll bring it to Muddassar, and he'll introduce himself and go into the presentation.
Thank you, Anne. Thank you, Gary. Hello, everybody. Good evening and maybe good morning to some, or good afternoon to some, depending upon where you are in the world. And that's actually a very interesting point. Anne is introducing me as talking about career paths for software engineers. Generally in the United States, often after you get your degree, but I've been recently hiring in South America, where many engineers start their careers while they're going to college or while they're going through universities and getting their degrees, and both kind of go hand in hand. And it's an interesting thing to observe globally how things can be different. This small presentation that I've prepared is more broadly for just any kind of career path for anybody who's aspiring to become a software engineer. Just a brief bit about myself. I've been working in the software engineering industry for a couple of decades almost, which kind of makes me a bit of a dinosaur. I've worked with in the financial industry, in the consulting industry, and I've worked for Amazon for a little bit, and then now I'm working with Bayer. Bayer's research and development arm, Climate Corporation, for agricultural technology, the digitization of farming. So anyways, let's get going in talking about what do careers look like for software engineers. So I'll skip the agenda because it kind of makes sense if you look at it later. So I think the first question probably is coming to anybody's mind who's joining out of interest or out of curiosity is, do you really need to think about it? When I was graduating from college, and this is obviously a long time ago, I actually have no idea what career paths look like. I knew that I enjoyed programming. I knew that I liked computer science. I'd chosen that major, and I knew that I was looking for a job, and didn't really have an idea of how the careers were made. I did have a little bit of an idea that generally when you go join a company, you're going to have a manager. They must come from somewhere, but didn't really know how to become a manager, nor was I interested. So this is very true for most new hires in the software engineering industry. It takes them years to understand what are the different career possibilities. Maybe it's changed a little bit, but generally when I hire people from colleges or I see interns coming through, we have to coach them quite a bit. And as I've kind of listed down a little bit down in other points, most companies are not really vested in that. And there's a reason for that, right? The reason is technology or software engineering is not the basic, most important component of a company. Now, you could be working for Google or Facebook or Amazon or another heavily technology-centric company, and yes, they will invest, or they will have invested a lot in development of career paths of all their engineers. But many other industries, which very well may be because you're passionate about, let's say somebody's passionate about automobiles or automobile industry. Technology is something that's heavily used in all industries now, but not everybody knows how to do technology right, or how to have the right engineering departments. And it's still something where they fall behind in developing good career paths. So for you guys to know this, well, I believe can give you a little bit of an edge in how to shape your own interests, how to shape your careers. And even if you go work for a company where technology departments are in their relative infancy as far as understanding these things, knowing these things could help you shape those also. One natural question that comes, which a lot more so is a luxury of, let's say, in the Silicon Valley or in the West Coast, is that what about interns? A lot of people get internships. They must have an in on this. Well, believe me, I have had a lot of interns that even after they join the company as returning interns, still it takes them a few years to understand what it is to make a career, what kind of possibilities exist, and so on and so forth. So anyways, there's a little bit about why, and let's move on into what do software engineers do once they're kind of finished college. And I'm gonna focus more on software engineers and not on the overall computer science engineering or computer science field, because when I was doing computer science, I also learned about hardware engineering. I think the class that I took was called digital logic design, and we were doing AND and OR gates. That's pretty much most of what I remember in that. And also computer architecture class, where we were looking at bits and bytes and doing computer arithmetic. So again, there's a lot of other fields that computer scientists can get into, but in the software engineering side, I've listed down some of the different kind of software engineers that I have noticed in my career. And many of these work in the company, or we have these specializations in the company that I work in. So obviously starting from very simple, people that are, front-end web developers, JavaScript being generally the language they usually work in, but there's other flavors of that. Now there's so many handheld devices in mobile, so that's another specialization. Front-end mobile engineers working in either the iOS platform or Android platform, and who knows, there might be new platforms in the future. Going down build tools engineers. So that's another specialization. This is more recent because packaging has become so specific for not only mobile and web platforms, but also for many different, like if you're developing AWS, for example, AWS services code, how to package that code so that it can easily go deploy in a container is generally something that a build tools team engineers handle. There's a lot of scripting involved, understanding of different platforms. You have to kind of keep up with whichever platforms you deploy software to. Just keeping going down the list, system resiliency engineers, SREs. These are DevOps. That's another name for them. Then data ops. Back in the day, a lot of people that would fit under data ops engineering would be database administrators. So traditional databases, which used to be often relational databases, would definitely require pretty heavy duty database administration. Even now, there's still quite a bit of a need in data ops. Orchestration engineers, middleware that kind of connects the front end engineering to back end engineering. Support tools engineers, these are internal tools building engineers. Again, it's software, but if it's not user facing, generally they get classified as support tool building engineers. Deep infrastructure engineers, the software they tend to develop is more closer to the core. I mean, it's not closer to user facing. Then there's API engineers. These are generally backend engineers, more with domain model building or the models for database domains or data logic domains, algorithms. I did list order to cache engineers. There's generally the monetization aspect, and there's specialization with interfacing with platforms like SAP and Salesforce, for example. I also added a category where I've seen performance engineers. So generally, when it comes to large scale computing, you need specialization in performance engineering. And I didn't mention before because I wanted to bring it last, just generic full stack engineer. So this is a lot of what I did early in my career was full stack engineering, because a lot of the specialization that I've listed didn't used to exist actually several years ago. In other place, full stack engineers are still quite prevalent these days, is especially if you are going to go work in a startup in a really small company. People like versatility quite a bit. So trying to be super anxious to kind of go into and become one of these is probably not necessarily a great thing, especially if you're looking into startups and like really small companies. So these are the different flavors of software engineers. In Q&A, you guys are more than welcome to ask me about any of those. Some of these I'm more familiar with, but generally I can give you guys some answers towards specifics of each one of them. Okay, so that's software engineers. Like, what do they do generally right out of college or right as an individual contributor? Now, software is not only built by engineers. Software is what I call built by a village. You know, just like we say, a child is raised by a village. Generally, software is actually built by a village. So the next slide actually talks about the others. What other roles are there that help us build software? By no means this is meant to be an exhaustive list of all the people that work in an engineering organization, and it can be very different from a company to company. But amongst the companies that I have worked in my career, these are the roles that I see as prevalent, definitely in the Silicon Valley or in the West Coast. You have the engineering manager, which is the direct manager that manages engineers and projects. You have product designers, which are people that provide the visual design, especially for front-end engineering products. We have the product managers. Generally, these are both product designer and product managers generally fall in also adjacent organizations, but still, they work very closely with engineers. So product managers are people that provide us requirements, that guide us through the build out of product. We have software architects and principal engineers. So I'm going to bundle both of them together. Basically, a principal engineer is generally a more senior software architect, and they are much more so in the technology strategy of a company and the implementation of the strategic technology requirements. Synonymous to engineering manager is a director. Generally, a director manages one or more or multiple engineering managers. We have chief technology officers. They're more synonymous in the same path as software architects or principal engineers. But chief technology officers sometimes can also be the people that lead all technology or all engineering. Then there's some technical project managers, and I'll talk about some differences between a technical project manager and engineering manager and how do they come about. Sometimes, not always, there's also Scrum Masters, and this is very much related to the Agile manifesto of development. But the companies that follow a hybrid model in development, hybrid of waterfall and Agile, or just straight up waterfall, then Scrum Master is something that's definitely missing there. We have technical leads. We also have operations manager, and then I've also listed more often as far as an organizational leader, a vice president of engineering. Again, sometimes the chief technology officer and vice president of engineering can be synonymous, but generally speaking, they're separate roles, and I'll talk a little bit about how they're different. Again, if any one of these labels interests you and you have more questions, we'll bring the slide back for you guys at the end, and you can ask questions about some specifics if I don't cover them in detail a little bit later. One question that very much that comes to people's mind when they hear a presentation like this, or when they're just beginning their careers and they're like, okay, Muddassar, why are you telling us about all these other roles? Like, what is the ratio like? Are we talking about 1-to-1? Are we talking about 10-to-1, like 10 engineers and 1 manager? Is it 5 engineers and 1 designer and 2 product managers? Like, what does the ratio look like? So actually, the right answer to that is there is no exact ratio. You can go to different companies' manifestos and you can see, some people say they like to see 2 pizza teams. 1 engineering manager should never have more than 7 or 8 engineers. Some people don't like a lot of hierarchy, meaning they don't like engineering manager, then director. Then some companies like, hey, you have your VP of engineering and director and then 60 reports, something like that. So it's different. What actually dictates this is quite a few things. I've highlighted a few things. The kind of product you're developing actually has the biggest impact. If you're developing a user-facing social media application, you're probably going to need quite a few designers. If you're developing just the IoT device interface, very simple UI, probably not going to need a heavy-duty design on that, except just how physically usable something like it is. If it's banking software, that's for internal users, and it's entirely different. They have like 6 monitors up if you're an investment banker, so you have a lot of real estate. So it's completely different on what you're doing. Industry also has a big say in that, as far as like finance industry has its own say. I've also worked in finance, ag tech, retail. I'm sure I haven't worked in media myself, but media has probably a lot to do with the look and feel of things. Imagine Netflix UI being ugly, probably not going to work. Medical, accuracy of records, data quality it's not just not an option, it can get you in trouble, so it's different needs over there. And then, if you really want to know what's going on, read up on a company's history. Where is it coming from? Is it the Ford, 110-year-old company, sorry, probably longer, a 120-year-old company with a lot of legacy. So, it's very difficult to change culture over there. So you'll find, relics of very old management styles over there. And also, read up on principles. One of the most boring things that people find when they're trying to join a company is like, oh, I got to read what principles the company operates on. There's a lot there, actually. There's a lot of hidden meanings in what companies' principles are. Size matters huge as far as how the organization is, how the organization works. So big companies, for example, have a lot of specializations. They kind of need it. Getting software built with multiple dependencies in a big engineering organization in a big company, a lot tougher, because you can have a lot of competing priorities with different teams. So the role of a technical project manager becomes extremely important there. Okay, so now what I'm gonna move forward to is something that I'm familiar with in the last 2-3 companies, but as I walk you guys through this kind of a chart that I've developed and how a career path progresses for a software engineer, by no means it's a hard and fast rule, but generally I found it to be true, and there's some logic behind it. So we're going to start right here. Hopefully you guys can see my pointer. When you come out of college, you're a software engineer. And there's many definitions of a software engineer. Some people call it system analyst. Some people call it software developer. There's all kinds of, labels that they give software engineer. But at the end of the day, you're a software engineer, and then X amount of time later, and again, this varies, right? And it really depends more on you have to essentially be classified as a senior engineer. And again, labels are different in different companies. So don't hold me back, hold me accountable for, hey, did Muddassar give me the right label when he gave the presentation? It's more about there's just this arbitrary line which you have to cross where you are an engineer, and after 1, 2, 3, 4 years, you will eventually be recognized. Okay, this person is senior, and we're going to value him or her as a senior engineer. So senior engineers now actually have 3 arrows going out of them, and I'll tell you guys why. Once you're a senior engineer, you can be a senior engineer for a really long time. And most good companies will really value you as a senior engineer, because senior engineers actually produced the most volume of software in any company, because they make the least amount of mistakes. They don't do other things. They produce a lot of code, and they're extremely valuable commodities, right? And most companies actually really like to pay their senior engineers as is. Like they don't, I mean, if I was running a company, I wouldn't care how long somebody wanted to be a senior engineer, as long as they were performing at average or above average, that would be extremely good. Now, as people move on, and a lot of people aspire, very natural progression for senior engineers is to become a technical lead, where instead of just developing code, a technical lead is somebody, once the requirements come, they break down the tasks. So not only do they develop code, they also break down the tasks and make assignments, or basically set up the work that multiple other engineers can work with them, or on a project which they break down. That's a technical lead. Very natural progression that happens from senior engineer to technical lead. Again, there's labels. Some people call it staff engineer, so on and so forth. But essentially, that's a technical lead. Senior engineers sometimes also move towards software architecture. They're not interested in project breakdown. They can be interested in deep diving into technology. They're more interested in developing architectural patterns, or looking at the overall organizational technology strategy and marrying that with the business requirements of a particular project, and creating architectural designs for projects. So that's another progression that happens. Sometimes I also found that senior engineers first become technical leads, do a little bit of project breakdown, not like that aspect too much, and then move to architecture, right? Because as you get to do it, there's some people that take to it very naturally, the technical lead work, and some people get frustrated with this, right? Because the requirements are not always great, or people try stuff and they don't like it. That's totally okay. One thing that I want all of you guys to recognize is that you can go backwards also. My arrows don't necessarily show that, but many times it happens where people would try to be a technical lead or eng manager, and they don't like it, and they go back to technical lead work or a senior engineer role. And that's totally okay. It's happened a few times for people that report to me, and I'm completely comfortable with it. I actually tell them right when they're about to try something that, hey, I want you to give it an honest shot, but if you don't like it, it's okay, So again, coming back to the subject at hand, you can, from a technical lead, you can go to a software architect. Now there are some dotted lines that I've also drawn from senior engineer and technical lead, and these are pretty unique. I've just mentioned them. I'm not going to go too deep into it, but sometimes at senior engineer level, you recognize that, look, I like technology, but I like the business aspect more, or the design aspect more. As a senior engineer, from a product manager, it generally happens as a technical lead, because you have to have looked at product requirements and transformed it into software development plans. But you can make a switch to a product designer. I've seen that happen also, which is a completely then you go into an adjacent department for product and design. And as a technical lead, you can also go into completely product management, where you're now developing requirements, right? So very natural, right? As a technical lead, you're working with requirements, you develop an affinity towards developing requirements, and then you move into product management. So that's certainly something that I've also seen happen, and some companies encourage that. It depends on how technical of a nature a product has also. Okay, so now moving on, I'm going to first cover this bit because this is pretty straightforward. Sorry, one second. So from a software architect, it's a linear progression. The broader and the deeper you go into technology of your specific domain and industry, the more natural and the faster your progression is going to be into a principal engineering role. A principal engineer is not only just a better software architect, but a principal engineer is somebody who becomes more technology agnostic, meaning like you won't find, it'll be harder for you to find, let's say, an Android principal engineer. It'll be easier for you to find a mobile principal engineer, mobile technology principal engineer. See, what I did was broaden the role or the responsibility that a person has. So that's generally the principal. Principal engineers are they handle broader areas of technology. The breadth and the depth both increases. And finally, depending upon a company's size and how far they go deep, from principal engineers, you can also move into a distinguished engineer. And a distinguished engineer is generally somebody, depending upon the size of a company, is somebody who handles multiple departments, technology needs, and vision and strategy, right? And final bit, we'll come to how a chief technology officer can also come from management, but generally, if you're going to be a CTO, you're going to probably come from principal engineering or distinguished engineering background, because as a CTO, chief technology officer, you are setting the technology vision for a company. And it's very much so, more often than not, it's something that you have to be quite strong in. Okay, now moving on the other side, which is where the individual contributing goes away, and then you start adding HR management or people management, is that before becoming an engineering manager, right, very rarely you will become a good engineering manager unless you have done some solid technical lead work, because a big part of engineering management is delivery of projects, and you have to be good at planning. This is a very natural progression that happens from technical leadership. Some rare times, once you go into software architecture, you can make progression into an engineering manager. But when that happens, you basically try your hands at software architecture, but it doesn't really go as you plan, or you don't want to go further. Sometimes some companies don't have the role of a principal engineer at all. And this is where I'm talking about career progressions are limited sometimes in industries that are not pure software. So some people move from software architecture back to engineering manager. It's a hard shift, just to be fair, because without technical leader work, which is, project breakdown, delivery planning, it's very difficult to be a successful engineering manager. And then from engineering manager, there's two roles. And again, this is kind of deeper in your career, because very rarely you find a director or a technical project manager that's very new after graduation. This is a few years of progression at least. But as an engineering manager, you move to either director. Directors are generally in roles where they're managing multiple engineering managers, at least minimum 2, depending upon the company's setup. And technical project managers is a departure from people management. So the interesting thing that happens is some people, when they do engineering management, they become really good at project delivery, understanding requirements, and transferring them into great execution plans. But after doing some people management, meaning managing people's careers, they come to the conclusion that that's not something that they want to do. So this is very much a role for the people that generally shy away from the people management, but they love project management. So technical project management, this actually is also very prevalent in big companies because, as I mentioned a little bit earlier, in bigger companies or bigger engineering organizations, there is a lot of dependency management that has to happen because everybody develops their components, and there's a lot of cross dependencies that have to be managed. And without technical project managers helping projects across multiple teams and pods and organizational boundaries, it's extremely difficult to develop complex software. Finally, directors and sometimes senior technical project managers and directors of technical project management, either one of those can progress to what I consider generally the leader of an engineering organization, which is the vice president of engineering. I've seen that model at work both at Amazon and at Climate. Chief technology officer is usually at the same level as vice president of engineering, and they are the ones that are setting the technology vision. Sometimes the chief technology officer is missing entirely so. Sometimes the vice president of engineering is missing entirely so in their one role, but they can be separate. So again, keep this slide in mind also. Maybe there's some questions that come up later, but what I'm gonna hit next on is looking at, I've basically taken the roles that I kind of shared with you guys, especially in the previous slide, and put some highlights on what their roles are affinitive towards. Like, what do you have, if you have affinity? So first, like this first one's got to be very obvious, right? If you're going for software engineering, you're a computer scientist, you have to love problem solving. I mean, that's why I fell in love with computer science. That's why it was hard for me. And then once I got it, it was like so many eureka moments. You write some code, you compile it, you'll write some good tests, you'll figure out whether you got the problem right or wrong. So that's great about software engineering, and you gotta love that. The other thing that I wrote is something that the trick question that somebody smart once asked me, that why was computer science invented? So all computer scientists should know that. It was generally, it was invented because you want fast, repeatable, accurate solutions, in an automated way, obviously, because, if you put humans to it, you probably need thousands for a small problem in today's world, at least. So software engineering, again, seniority doesn't matter, junior, senior engineers. I just put a couple of points over here. If you want to get into architecture, your love for technology has to be just a little bit deeper. You have to be an abstract thinker. Thinking very linearly is probably does not make for a great architect or a principal engineer. You have to be able to think in abstraction. Data modeling is something that I understood the value of quite late in my career. But for those of you who are really passionate about technology, probably great for you guys to spend more and more time on data modeling. It is what all software is built upon. Good data model generally means good software. Bad data model generally means flaky software. And again, in the same vein, scale is something that architecture is all about, right? Those of you have seen some videos on whether it's Facebook or Twitter and the kind of complex scale problems they have to solve. They're pretty hard, So I've listed out some important things for engineering management or director role. I put it italic because director roles sometimes obviously also have to worry about some of the role needs for vice presidents or CTOs. So like you got to be good at delivery, execution management. You have to understand contingency. How do you plan a project? Engineering management and director is all about the most fundamental principle in human interaction, which is called trustworthiness. When you run a team, if you can figure out how to run a predictable team, you're going to be a good engineering manager and subsequently a good engineering director. But that's a hard thing to do. And it takes quite a few tools and disciplines to become good at that. You, as a manager or a director, understanding people and the art of people management is very, very important. I said people, but really understanding engineers, actually, because you're managing engineers, not just any people. So generally coming from engineering background becomes very important. Also, another very important aspect is process development. We are continuously taking aspects and trying to document processes, always looking for improvements and how to do things. As a technical project management, very naturally, you have to be extremely organized, great at planning. Well, one thing people don't realize, if you're an extremely empathetic person, it makes for a great technical project manager, because you're working with other teams and understanding their constraints. And people that are not empathetic, people would think that they can really get all projects done, but they're not good project managers, at least from my experience, at least in the long term. They may succeed in one project or two projects, but longer term, they fail quite miserably. And I've listed, a few things for, the higher level leaders, and like whether it be a vice president, CTO, senior directors. Strategy becomes a whole lot more important. Overall organizational goals, overall team dynamics, finances become very important. Recruitment becomes very important, or recruitment strategy becomes very important. Globalization of talent becomes very important. And not architecture, but architectural requirements development becomes very important. I've created a yellow box for product management, business and strategy. Again, that's a field in itself. It's adjacent to engineering, so we won't go too deep in here. Okay, so having covered this, and again, there's a lot more to say about this, and maybe in some Q&A we can answer some more questions if you're interested in one particular aspect more than others. The next few slides, I'm just going to share some broad principles as you guys kind of go into your careers in future. As you get going, highly encourage you guys to find a mentor or find a few mentors if you can. If one does not, nobody's a perfect mentor. So if you try one, it doesn't work out. But be anxious about finding a mentor. Don't wait. Don't think, oh no, I don't need somebody to talk to. I can just browse the net or something. People that are willing to be a mentor, and if you guys are good seekers or good mentees, it's very, very important and goes really long ways. And just a small little picture right next to it. When you get a chance, be a mentor, because it's important. There's no substitute for it. That's all I have to say for that. Okay, the other thing is this goes for all careers, but especially for computer science, software engineering. I worked in this industry for close to 20 years. This is about continuous learning. What I knew in 2001 or 2002, it's irrelevant now, actually, in many ways. And of course, it's I've had to build up on what I knew then. But please make sure you value continuous learning. Careers are daunting. You go work for a company. Not every company is going to be as vested equally. There's no perfect harmony with all companies, right? So not every company is going to try to build your careers and stuff like that. You have the responsibility to portion off sometimes some energy for learning. And the more, obviously you can't dedicate 40 hours a week on this, because how we get your work done, but definitely dedicate some time throughout every year, be honest with this aspect. And finally, this is the last slide, and then we can move on to questions. Maybe I'm probably a little late, but one key difference about engineering and academics is that what you guys are doing right now is academics, the perfect program, the perfect software, the perfect principles. I just want to make sure you guys know that as you get into the industry, software engineering is meant to be about trade-offs. And the trade-offs of what the business requirements are, what commitments are there, and how do we find the right balance between the two without sacrificing quality, at least in my organization. And one very important question I wanted to share with you guys as you guys go forward in your careers is, in your interviews, definitely think about asking this question. Can you please share with me what career path you have for individual contributors? And that answer will tell you a lot about that company. I won't tell you what the right answer is, but it'll definitely give you something to think about, which is very important. Okay, I know I have very few minutes left, so I do want to turn this over into any kind of questions that any of you guys have. I'm gonna let Anne and Gary guide me on what is the mechanism on how questions can be asked or answered.
All right. Okay. So thank you for your presentation. For those watching on the YouTube stream, feel free to type in the chat any questions you have. We do have one question on the Zoom channel right now. So the question is, when you first hire a new software engineer, how do you weigh the different aspects of their resume? So whether they have a bachelor degree or some other degree and where they get that degree from versus their years of working experience versus their contribution to open source projects. How do you weigh all of those different aspects?
So I think all those aspects are important, but I'm not gonna just say all are important equally. I think contributions to any kind of open source projects where engineers who are hiring or doing technical interviews can actually review their code, actual code that's been submitted, I think would be very valuable. Next would be their work experience, meaning if they've done some internships, if they have the opportunity to work in a professional setup. Now, obviously, working in a technology industry is probably the most preferable, but really any professional setup or any professional experience really helps, because a lot of it is, are you somebody that we can work with professionally? Where we can ask you for a commitment, and then you will do your best to keep the commitment. Hopefully that answers it a little bit.
All right, thank you. We have another question. When you're hiring a mobile application developer, what kind of experience and degree do you normally look for?
So I think this depends upon what the company's maturity is as far as developing their mobile teams, right? So if we're looking for a college hire, for example, I'm assuming this question is more for that. We would generally look for definitely object-oriented programming experience through college. If somebody hasn't taken any object-oriented programming courses, that'd be a hard sell for me. The other thing that I would look for is some projects in their college that they've done that are related to mobile technology. Naturally, any internship that are related, or any source code that they've contributed in the mobile space. But those depend.
All right, thank you. And then I guess one question I have is, could you elaborate on what software architects do and kind of the difference between that and a software engineer?
Sure. So when you're an engineer, generally requirements are given to you, or tasks are already broken down for you, or you can sometimes help break down the tasks, but you have the requirements. you have an architectural manifesto or what architecture you're going to develop software in. And then you marry the architecture with the requirements, and then you build solutions, right? Now, obviously, the architecture is not going to tell you how to write the perfect algorithm. That's still the software engineer's job to make sure, the O notation for an implementation is right, and you're not creating a bunch of, or not handling all the exceptions, for example, if you're doing Java code, for example. You're still responsible for that. But there is an architectural manifesto, like, hey, use these patterns, develop using these frameworks, build these components or these kind of components, and build them in these packages, right? And here are the requirements which you use to build that. So that's the software engineer's job. He or she is marrying the architectural requirements with business requirements, right? And creating software. The software architect at the first level, remember I said there's an architect, then you get to principal engineering and yada, yada, yada. So let's start with the architect level. And the principal engineer or the CTO, depending upon how much the hierarchy is, develops the architectural requirements, which means this is how architecture needs to be developed, right? The architect takes the requirements and develops architectural patterns. And also, when the high-level requirements come for programs, they create the high-level architecture, which becomes the architectural manifesto or architectural paradigm using which software is developed by the engineers. I probably spoke a mouthful, but that's kind of how it works.
Great, thank you. And then we have another question. Can you explain what a system resiliency engineer and a Scrum Master do on a daily basis?
Sure. So let's start with the Scrum Master. That's easy. So those of you who have studied Agile software development, you have a daily Scrum. Somebody has to run that. They have to work on the tasks, on like what tasks were completed in the previous sprint, what needs to be in the next sprint, how do that marry into the projects that are trying to be completed, measuring the velocity, making sure that every engineer's velocity is fully utilized, measuring the overall team velocity. So that's all Scrum Master work, Now the other one was SRE engineer. So this is system reliability engineer. So just like the word kind of hints at it, there are in software houses, when software is deployed, there are many monitoring tools that are in play to make sure software runs right? Getting those tools configured, monitored, addressing issues, building the right containers with which software is deployed. That's all system reliability engineering and monitoring team's job. But again, another word for them is DevOps.
Great, thank you. And then since we're a little bit over time, my last question is, what factors between a software engineer and a senior software engineer, like what can you do as a software engineer to move up to senior software engineer besides just like working at that company for a long period of time?
So I think a lot of it has to do with independence, right? An engineer right out of college or until they're senior engineer, again, there's a lot of there's ambiguous dotted line there when you become a senior engineer. The key, most fundamental thing is how independently you can work, right? Because a junior engineer or beginning software engineer requires a lot of hand-holding, explaining of the domain, explaining of the requirements, explaining of the architecture. A task can't just be given to them. It has to be explained further. There's a lot of Q&A that goes on. Senior engineer, you give a group of tasks, you expect estimates, right? And you expect them to be able to generally handle. That doesn't mean they don't get to ask questions. Of course they get to ask questions, but their questions are more things that further clarify requirements, right? Or further clarify architecture. So they are basically asking questions which are identifying gaps in requirements and identifying clear gaps in architecture, right? Whereas junior engineers are trying to understand how to implement architecture or how to fulfill a requirement.
And then we have one last question on YouTube chat. What is the age group for most companies, software companies hiring internships?
So this depends a little bit on the size of a company, but generally speaking, most companies go for juniors or seniors for internship. So it's a very natural business related question, right? If I'm gonna invest X amount of money in getting an intern in my company, I want them to be a junior, so they'll go back to school for 1 year. They're going to have the experience fresh on their mind, and they're going to come work for me because I'm going to give them a good experience as an intern, and I'm going to judge them. And if I like them, I'm going to hopefully try to make sure they like my company and my culture also. So next year they just join, So it's an easy, sell. Because if I go do this for the sophomore engineer, they're probably going to go for another internship, probably not to the same company, because generally I would like to get a varied amount of experience. So then it's a harder sell. So that's the answer, at least for most companies. Now, the bigger the company, then they go for sophomores and even freshmen, depending upon how much money they want to invest in college grads or people that are still in college, and how much they believe in their culture, that they're okay with taking more risk with more junior college students.
All right, thank you. So I think that's the end for our Q&A. So thank you, Muddassar, for the presentation and answering these questions. And then I'll bring it back to Gary, who has some updates for Hack the World.
Yeah, definitely. Thank you so much. You gave us so much content, and all of it was so insightful, and I think all of us learned a lot.
You guys are most welcome, and best of luck with all the rest of the stuff you guys are doing. Super excited for this.
And for those joining us on stream, and if you're attending Hack the World, make sure to check out our social media, which is at synHacks on Instagram, Facebook, and LinkedIn, and synHacks team on Twitter, because that's where we'll be updating and posting about more events similar to this. But our next upcoming event will be actually our daily Outlook live stream, which will take place tomorrow at 11 a.m. Pacific Daylight Time. And we'll be giving a brief overview about what to expect during the day. But that's all we have for today. And thank you for joining us, and have a great day.